Hello everyone. Hello everyone. Yeah, so I welcome you all in this session. So let's discuss some of the important uh, topics that we are expecting that the questions will be asked from those topics. So you can even ask the doubts if you have. You can ask the doubts in the chat. Okay, let me open the chat, please. Yeah. Okay. Okay, Vandana says, please discuss the on to function. Okay, first we discuss the what are the important things that are from your unit. Okay, so one that is the introduction of the set theory that you know. So from the sets, they may ask you the definitions. They may ask you the definition of the MPT set. They may ask you the definition of the singleton set. Okay, and sometimes they may give you the a set and they will ask you to just write it in the set builder form or write it in the roster form. Okay, and these things are very easy that you know already. And the cardinality of the set. So for example, if the cardinality of a, as you know, the cardinality of a set is actual the number of distinct elements in a set. And they will say, for example, the cardinality of a is n, the cardinality of b is m. What will be the cardinality of a cross b? That you know, that will be m cross n, m times n. Okay, so yeah, we will discuss the onto function. Okay, if anyone have the doubt, you may ask you can ask here in the chat. We will discuss those things. Okay, so then in the types they may ask you what is a finite set as a definition of finite set: a set that has the finite number of elements. Okay, so that we can say, if as a is said to be a finite set if the cardinality of a is n is a natural number. Simple. This is called the finite set. So the finite set is that set in which the cardinality will be some particular natural number. Simple. They may ask you what is an infinite set. What is the infinite set? A set whose cardinality is infinite. That's called the infinite set. They may ask you what is a null set. The set that has the cardinality 0. And we are writing this set as the empty set phi or the void set. Clear? Yeah. The okay, I will just okay, sir, please say hi to all of us by name who are there in the chat. Okay, I will tell, but first we will complete. Okay, you have the exam tomorrow, so we are here for the exam. Okay, so now they may ask you what is a disjoint set. So the disjoint set, we say a is disjoint from the b if the intersection of these two sets will be empty. Okay, so that means there is no element in common. So they may ask you what is a disjoint sets. Okay, so equivalent set, yeah, this one is important. Equivalent set. So before we discuss the equal sets. So if they ask you what is a equal set, you will say two sets are said to be equal. Two sets are said to be equal if they have same elements. For example, A is equal to A, E, I, O, U, and B I can write U, O, E, I, and A. So these two are equal. The equal number of elements as well as the elements are equal. What is equivalent set? We say that a set A is equivalent to a set B if the number of elements in the A is equal to the number of elements in the B. For example, we will take A is equal to A, E, I, O, and U. I will take B is equal to 1, 2, 3, and 4, and 5. So now the cardinality of A, that is 5. The cardinality of B, that is 5. So A is equivalent to the B. Okay, clear? Okay, so that is the equivalent set. Okay, equal sets we have discussed it. Then they may ask you the, okay, the question will be from the union. Okay, they will not ask the definition of the union, but first you have to understand what is the union. So where I have already uploaded the video regarding the union, intersection, and all. But the things that are very important, the expected questions, so those questions we will discuss here. So they may ask you the questions from the Venn diagram. Yeah, we will discuss the power set and the partition, don't worry. Okay, so they may ask you the questions from the Venn diagram. Okay, in the Venn diagram they may ask you, for example, draw the Venn diagram of A union B. So what you will do, just make one universal set as a rectangle. Draw by convention A and B, let's say they are not disjoint. So now A union B is the all the elements either from A or from B. So you have to shade the area of A union B. Simple. Okay, the questions will be like this. So they may ask you the questions, for example, some to draw the Venn diagram of some difficult these set identities. Okay, so you have to draw those Venn diagrams. For example, they may ask you draw the Venn diagram of A minus B. What will you do? Draw the universal set, draw the A, draw the B, and subtract the minus B. So this is the B part that's common with the A, isn't it? So this one. So the part that is A minus B is this one. So you have to shade this one part. That's the black. Okay. Yeah. We will discuss the questions only. So they will ask you the questions from the Venn diagram, and I'm sure about this that one of the question either from 2 marks you will get from the Venn diagram. They will ask you to draw the Venn diagram of the sets. Okay, so you just write here. If the Venn diagram is clear to you, then we will I will go to the partition. That's important in this part, that is the set theory. Is this Venn diagram clear to everyone? Write in the chat. Write in the chat. In Venn diagram, sets are mentioned inside a rectangle. Yes. So Venn diagrams is clear. Yeah, we will discuss some difficult questions. So here we are just discussing the questions that are expected in the exam, means what type of the questions they may ask. Okay, what type of the questions they may ask, means they can ask the questions from the Venn diagram. Now the another thing that they can ask, so that is very important, that's very important, is the algebraic identities. Okay, so that is the algebraic identities of the sets. Okay, just give me a second. Okay, so that is the algebra of sets. Here you have the four identities, very important. First one, that is idempotent law. In the 5 marks question, one of the law will definitely be there. Idempotent law, you know what is that? A union A gives you the A intersection A gives you the A, and you have to prove it. Okay. Okay, someone said Venn diagram for A intersection B union B intersection C. We will do it. Okay, so this identity may come in your exam and you have to prove it. Okay. So now, okay, so Rohit says that you draw the Venn diagram such that you have the A intersection B union B intersection C. This is your A, this is your B, this is your C. A, B, and C. Now you have the A intersection B, and you have the B intersection C. So this part is the union. That's the total. Okay. That's A intersection B union B intersection C.